Welcome to this technical presentation on Tersus GNSS receiver for the Equipment Procurement and Supply Program of Nigerian Institution of Surveyors, Ogun State Branch. It's presented by Sacredion Nigerian Limited. First, I want to appreciate and thank the Chairman, Nigerian Institution of Surveyors, Ogun State, the Chairman, Education, Research and Development Committee, Nigerian Institution of Surveyors, Ogun State, every member of the Nigerian Institution of Surveyors, Ogun State, and all the members of the committee for selecting Sacredion Nigerian Limited as a procurement center in this program. We will not take this for granted. So let's go on in the presentation. The voice at the background you're hearing is Surveyor Okorocha Vincent Chika. I'm a registered surveyor and a full member of Nigerian Institution of Surveyors, a member of the Editorial and Publication Committee, Nigerian Institution of Surveyors in Lagos State. I am the principal consultant of Sacredion Nigerian Limited and the direct contact person in Sacredion for Tersus GNSS Incorporated in Nigeria. I've been involved in GNSS research since 2009 and currently on a PhD program with research interest focused on integrating GNSS and UAV for terrain modeling. Let's look at the outline of our presentation. We'll go through a brief introduction of Sacredion and our partner Tersus GNSS. We'll talk about why you have to choose Tersus GNSS, the various models of Tersus GNSS, modes of operation of Tersus GNSS, accuracy performance of Tersus GNSS, the warranty options available, training and after sales support, various variations of Tersus GNSS models, various price variation of Tersus GNSS model. We'll look at volume discount offer, then we'll now take questions and answer. We hope this presentation would be an interesting one for everyone listening and joining us in this online forum. Now let's look at a brief introduction of our company. Sacredion is an IT engineering and surveying company, and we are focused on GNSS observation and UAV mapping in surveying activity. Sacredion has been involved in UAV and GNSS operation and has carried out several projects in this line. We are the exclusive partner of Tersus GNSS in Nigeria, and we are also an enlisted company by the Surveyors Council of Nigeria. Tersus is a GNSS OEM company that empowers users who have been dreaming of being born to fly with high precision GNSS RTK solution. From unmanned aerial vehicle that needs centimeter position accuracy in dynamic mode to drone delivery or aerial survey that requires stable performance over long duration. And Tersus design and manufacture lightweight, smart and precise RTK module that enable large-scale drone deployment in a cost-effective way. Tersus is a global company that has headquarter office, the head office in Tersus in China, and we have other global office in the USA and in Australia. The USA covers the Northern America and the Southern American region and some part of Europe, and the Australian company covers European and the Australian region of the world. And it is a pleasure to make this presentation and talk more about the offering of Tersus GNSS in collaboration with Sacredion Nigeria Limited to the Nigerian Institution of Surveyors, Ogun State Branch. So why Tersus GNSS? Tersus GNSS focuses on research and development in providing affordable centimeter precision GNSS solution to improve the quality of life for everyone. We understand that surveying is the bedrock of any meaningful development. And if surveying is the bedrock of any meaningful development, it means for the quality of life of people to be improved, various surveying application has to be done in the right accuracy and precision. So Tersus has looked at this, and every research and development is focused on just GNSS system for surveying applications, not total station, not other solution, but GNSS. And this application has been developed for precision farming, for agricultural application, and for surveying application, for integration with UAV, achieving precise dynamic motion tracking while attaining stable performance at long extended ranges in real time. So the Tersus RTK system can cover extended ranges even in the entry IP operation and in the real-time radio kinematic operation. And we can have ranges as high as 30 kilometers using our radio system. The Tersus GNSS RTK OEM board and receiver offers centimeter precision positioning and versatile compatible interface for operation in challenging environments. So it doesn't matter the environment you're working in, if it's in a water environment, a harsh environment, or even if you're scared of your equipment falling on the ground, Tersus has got you covered. With a focus on only GNSS, Tersus has been able to improve performance far beyond the norms in the GNSS industry. And this performance are in the area of the system being water resistant, the system being so hard and rugged that it can withstand a fall on a hard surface, and also the system being able to track under canopy. In line of this, we shall be taking three specific tests. We shall be showing you three specific tests. One, the Tersus OSCAR being thrown in a pool of water. Two, the Tersus OSCAR being thrown on a hard surface and the performance still continue. Then the third test we will take is the Tersus OSCAR system being used under canopy and will still achieve fixed. So these are possibilities with the Tersus system.
Make sure you show the surface.
Yeah. Tested the equipment, this OSCAR base, Tersus OSCAR base, used under canopy and it's fixed. The solution is fixed. You can make your observations under canopy. You can see covered constructions around. And the equipment is fixed. Solution fixed. Come over. It's currently tracking 29 satellites and fixing this point with 26. Tracking 32 satellites, fixing this point with 30. You can see the PAP. This is the parameters of the equipment. fixed. The solution is fixed. We're making observations under canopy. This is a nice, very important upgrade that has been instituted in the OSCAR variant. You can make observations under canopy, under cover.
As we have seen in those three videos, we saw that the GNSS receiver was thrown in a pool of water and it did not go off. The performance continued even after 30 minutes. We also looked at the video of how the Tersus OSCAR system was thrown on a hard surface and it continued to operate, and the precision of the point that was observed remained stable. We also looked at the video of how Tersus OSCAR was being used under canopy with one of our surveyors looking at it, and you saw how it was still fixed even under canopy. So let's move to the next slide. Let's look at the various model of the Tersus GNSS. One, we're going to take the Tersus David GNSS RTK system. This is the low budget range of the Tersus GNSS, and it has three options. One, the Tersus David GNSS network mode. Two, the Tersus David GNSS with the 2-watt base radio, which can cover 5 to 10 kilometers. Then the Tersus David with a 30 watts base radio, which can cover 20 to 25 kilometers. What is the difference between these three? Now note, the Tersus David network mode does not have radio, but it transmits RTK via internet protocol through the Tersus N-trip caster operation. So even without the radio, the base can be used as a core station and you transmit RTK via internet protocol. Note, every course transmission from the base to the rover is based on IP, internet protocol. So that is also what is achievable using the Tersus David GNSS network mode. Then the second option is the Tersus David GNSS with the 2-watt radio. This one, as you can see, this one. So with a 2-watt radio. So with this option, you can have the radio transmitting at a distance of about 10 kilometers, and yet the observation is still fixed with a 2-watt radio. What you have here is a rover representation of the 2-watt radio, where we are using the Tersus David for a drone mapping, and what you see there is the ground control point that was fixed. So this is how the Tersus David 2-watt radio looks like. And for the 30-watt radio, this is how it looks like. The one the lady here is opening the box. It's a bigger radio and it can cover as far as 30 kilometers, 20 to 30 kilometers, depending on the environment you are working in. If you've noticed, the Tersus David has cable connections because there is separation between the receiver, the radio, and the antenna, and they are connected together. That has a big advantage on its own. Let's take, for instance, the radio has an issue. You can still carry on static observation with the receiver even without the radio, because the radio is meant for RTK observation. But assuming everything is built in together, if there is an issue with the radio, you can't use the entire system. That's how it works, and that's an advantage that the cable connection is. And those cables we have, they are easily accessible if anyone gets missing. So the Tersus David has three options again. One, the Tersus David network mode. Two, the Tersus David with the 2-watt radio covering about 5 to 10 kilometers. Then three, the Tersus David with the 30-watt radio. And looking at this box, that is how the Tersus David looks in the box. This is how it looks in the box. You have the radio there, you have the receiver, and you have the antenna. Let's move to the next slide. So the feature of the Tersus David. Now the Tersus David has a free survey app that can be installed on any Android phone. Any Android phone. You can see the schematic diagram here. The Tersus, this is the receiver, this is the antenna, this is an Android phone, and it connects seamlessly without issue. The Tersus David, even though it's small, it has massive advantage. I usually describe the Tersus David with the incident of David and Goliath. No matter how big your survey project is, we can call it the Goliath survey project. The Tersus David, even though it's small, it can still handle the Goliath survey project. It can still bring down the Goliath survey project. So don't look at the size, look at the performance of the system. It's small, compatible, easy to handle, but it can perform so much. And it's a GNSS system tracking not only GPS but also tracking other satellite constellation. We'll talk about that in another slide, but more about that in another slide. But now let's just do that introduction. It's a GNSS system. It can track GPS, GLONASS, and BeiDou. That means it's multi-constellation and it has multiple frequency. It's a multi-frequency system. So, and also the Tersus David has a big advantage that the system is also a rugged system. And remember I said any Android phone with the newer survey app from Tersus can be used to operate the Tersus David GNSS. It has a 4 gig internal storage and it has optimal performance also in any environmental condition. Let's move to the next slide. Let's look at now the Tersus OSCAR. The Tersus OSCAR GNSS is the higher end of the Tersus GNSS range. It also has 3 options: the Tersus OSCAR Basic, the Tersus OSCAR Advanced, the Tersus OSCAR Ultimate. What is the difference between these 3 options? Only the Ultimate has tilt compensation, and if you look at this, the danger zone can easily be observed. Let's say you want to observe beneath a truck. You can use the tilt compensation and observe under the truck. If you want to observe also under a hidden point, the tilt compensation has that advantage for you to observe under a hidden point. If you also want to observe under an underground utility, you have that advantage also to observe the underground utility with this feature. And if you look closely, you realize that the Ultimate and the Advanced has internal storage of 16 gig, whereas the Basic has internal storage of 8 gig. Also, the Ultimate and Advanced has 2 years warranty, while the Basic has 1 year warranty. Then the Ultimate and Advanced LED display screen, whereas the David also have something like an LED display screen, but it displays just lights without writings. But in terms of performance and accuracy, the 3 of them has the same optimal performance. 3 of them have optimal performance under canopy. 3 of them have the same accuracy performance, which we are going to talk about and later. So the major difference is just in the ones we have highlighted. So the key features of the Tersus GNSS, like I said, it's multi-constellation and it's multi-frequency. So it has multiple frequencies. It can track GPS, GLONASS, BeiDou, Galileo, QZSS. The GPS is the satellite constellation of the US. The GLONASS is the satellite constellation of Russia. The BeiDou is the satellite constellation of the Chinese. The Galileo is the satellite constellation of the European Union. Then the QZSS is the satellite constellation of the Japanese government. So now the Tersus OSCAR can also has a channel of 576. Generally, from 2020 going forward, a GNSS system should be able to track a minimum of 300 channels, support minimum of 300 channels, so that if there are future updates that are coming up, all you need to do is to update the firmware and it can carry on with the future updates that are coming up in the development. So then the battery capacity, each receiver of the OSCAR has 2 batteries, which can last 16 hours combined together. Each battery can last 8 hours. So if you have 2 batteries in one receiver, you can work comfortably for 16-hour stretch if you can handle that. And note, it is waterproof, and it can also withstand harsh weather condition, harsh environmental condition, as we have presented in the video we've shared earlier. It's because of this powerful feature. It also have the radio range is from 410 to 470, so it has a wide range. What that means is that the big advantage, if there are radio interference in an environment where you are, you can easily switch to another radio to have better correction transmission. Also, it has the 4G capability where it can transmit RTK from a base station using the entry caster to a receiver. It has to another receiver, or you can also receive from a core station. It has that advantage. So the free subscription to Tersus caster service is provided to every user of the Tersus GNSS system at no cost. You have a unique user name and password in which you can use and transmit entry correction from a base to a rover without necessarily a radio. We'll talk about that later on. Now let's look at the image of the Tersus OSCAR. This is some of our team members holding the Tersus OSCAR system. That's what you can see here. This is the Tersus OSCAR system. You notice it's different from the Tersus David, and this is how it looks in the box. Then this is the Tersus OSCAR, as you can see, being held here. So the next slide will now go into the next session we'll be going into is the working modes of the Tersus GNSS. So the working modes of Tersus GNSS system. The first one we'll be looking at is the rover and the core. So you can have a single rover of the Tersus system and connect to core station. So what you see here is the schematic workflow. This is the satellite, this is the rover, and this is the surveyor connecting with his controller. He receives RTK correction from the core station to his rover, and at the same time the core station is tracking satellites in space, and the rover is also tracking satellites in space. This is possible through internet protocol via the entry caster. The next one is the base rover and Tersus entry caster. You have the base station receiving correction from the receiving satellite signal, the rover also receiving satellite signal. But the base is not using radio, but it's using internet protocol, and it's not the core station. But because Tersus provides a free entry caster to all users, so they can connect via the entry caster, and from the base it transmits to the rover. So this is possible. That's the second operation mode. Then what's the third one? The third operating mode is the base rover and radio. So the third operating mode is the base rover and radio. So how does that work? With that, which is the normal one that you have the base with the radio, the rover with the radio, and both of them are receiving satellite signal, and the correction in this case is not transmitted via internet protocol but via radio. This has an advantage that the surveyor can work anywhere even if there is no internet connection. But the limitation of the network mode is if there is no internet connection, there is no way communication can be done between the base and the rover. So the fourth operation mode is the static surveying. So with the static surveying, you have three receivers, 1, 2, and 3. So the surveyor, 3. So with these 3 receivers, each of them receiving satellite communication and storing their log file. So the surveyor is able to go and download this data into his computer and post-process to have the final result. Note, 3 receiver is the optimal method of baseline processing using GNSS. So when you have 3 receiver, you will have a closed loop, a closed network, and network adjustments can be done before the final result can be achieved. This is a slower method. Entry real-time correction is usually the fastest means of receiving correction from the base station. So let me just review what we've gone through again. 1, we talked about the rover and the core mode, the base, rover, entry caster mode. 3, base, rover, radio mode. 4, static surveying mode. So these are the 3 operation mode that is possible and achievable using the Tersus system. So now let's go to accuracy performance of Tersus GNSS system. We've placed them side by side so that we can see clearly that even though the Tersus David is a lower budget system, it still performs very good compared to the when we relate it with the Tersus OSCAR. The Tersus OSCAR is much more advanced because it can track GPS, L1, L2, as you can see, L1, L2, L2P, L5, GLONASS, L1, CA, L2, BEDO, B1, B2, B3, Galileo, E1, E5, E5B, QZZ, L1, L1, L1C, L2C. So it can track multiple constellations, much more than the Tersus David, which can track GPS, GLONASS, and BEDO. This can track GPS, GLONASS, BEDO, Galileo, and QZZ. But in terms of accuracy performance, both of them are GNSS system. Multiple constellation, multiple frequency. So that's why for single operation is the same. Single observation mode is autonomous positioning. 1.5 horizontal, 3 meter in the vertical. For differential positioning, which is having a float, if you are having a float, a communication between the base and the rover, you can be having 40 cm to 80 cm. But in situation where you are having high static observation, you can see 3 millimeter, vertical 3.5 millimeter. But for the David, we are having static 3 millimeter and 5 millimeter in the vertical. This is still very fantastic, 0.5 over cm. So this is also very good result. And in running the RTK system, you can see for the OSCAR, we're having 8 millimeter in real time and 1.5 cm on the vertical plane, which is also the same thing if you look at the David. So in terms of performance, accuracy performance, they are both the same. The bigger advantage the OSCAR have is the stability under canopy, which is a massive advancement from the norm in the GNSS industry. So what are the warranty options available? As you have seen, the Tersus David has 1 year warranty and the higher end of the Tersus OSCAR has 2 years warranty. So what are we giving? We are giving 100% satisfaction guarantee. We have several customers that have satisfaction guarantee. Reference can be given on request if you did. So with a 100% satisfaction guarantee, and 100% quality guarantee. What else would you want? So we at request we can provide references of some of our customers which you can speak with to share their experience using the Tersus GNSS system. So any technical issue that affect the GNSS receiver during the warranty period, Tersus Sacredion team bears all the cost of either a replacement or a repair where applicable. So the warranty is provided as fundamental quality assurance to all our customers with the issuance of a warranty card. So you are sure that this warranty has a card which you can make reference to if the date on the card is not the same date. If the date of the card has not been exceeded and you have an issue. So it's 100% quality assurance using this Tersus system, 100% satisfaction guarantee, and 100% quality guarantee using this Tersus GNSS system. For training and after sales support, we don't only just hand over the GNSS receiver to you, but we take in-depth comprehensive training with our customers, 2 days training, intensive training on the use of the Tersus GNSS system with continuous after sales support. This is what we have provided to every customer of the Tersus GNSS system. And our training portfolio covers general overview of GNSS, understanding GNSS coordinate system, map projection, and droid modeling. How can you integrate droid model into your GNSS so that it can convert the ellipsoidal height of the GNSS into the autometric height? That training will be provided. Also, static GNSS observation procedure, RTK GNSS observation procedure, entry connectivity and calls operation. This forms part of the training. How can you use your GNSS in entry mode? We'll give you access to the Tersus entry caster username and password so you can have a connection between your base and the rover using the entry mode. Then we'll also give you training on GNSS online positioning processing system. So with all these various options, the customer is optimally trained. His proficiency and competence is improved in the area of GNSS system. And even if the customer want to integrate it with UAV, he has an in-depth understanding on how this integration can be achieved. Price variation of Tersus GNSS model. I know now the question on everybody's mind is, Surveyor Okorocha, what is the cost of the Tersus GNSS system? So we'll look at the various options we've talked about. The Tersus network system, that option is not here. The Tersus network mode goes for 1.7 million, and that gives you the base and the rover kit in network mode only without radio. The Tersus system with the 2-watt radio that can cover 5 to 10 kilometers goes for 2.5 million. You can see the kits that are presented in each case. The Tersus David system that covers 30 watt with 30 watt base radio covering 25 to 30 kilometers goes for 3.5 million, and the Tersus OSCAR goes for 4.5 million. The first option of the Tersus OSCAR goes for 4.5 million. Then the next one we'll look at is the Tersus OSCAR Advanced, goes for 5.5. Then the Tersus OSCAR Ultimate goes for 6.5. But because of this procurement center and the idea that a large number of people will be interested, we are giving massive discounts that depends on the number of people that will be coming in. But before we go into the discount, let's look at the cost of just a single unit. Let's say you just need a single rover unit for connecting to core station. A single rover unit of the Tersus David is 1.2 million, and a single rover unit of the Tersus OSCARs, you can see, is 2.25 million. But there is massive discount still coming. Massive, big discount. So look at this. For volume order between 10 to 25 sets, Tersus Sacredion will be giving 15% discount on the regular prices, which has been itemized. But for order between 26 and above, Tersus will be giving 20% discount. So let's break it down and see. Let's take, for instance, we have above 26 people going for the Tersus David network mode, which goes, the regular price is 1.2 million. But because of that number, we'll be giving 20% discount. So 20% discount on this will be less 240,000. So if I take off 240,000 from this amount, that will give me 240,000 from this amount. So that will give me this minus 200. So you can see that will give me 960,000 naira, less than 1 million, approximately about 960,000 naira for just one unit. So this is the offering that Tersus is giving, and I believe this presentation has been broken down. We can see the various options and the prices that has been itemized, and so you have opportunity to have 20% discount if we're having 26 set and above. 20% massive discount offer. So we want to thank everyone for joining us in this presentation. You can see my contact details of your Okorocha. This is my phone number, this is my website. But we are going through the Nigerian Institution of Surveyor, the Education, Research and Development Committee. They have all our contact details. They have everything. We'll be liaising with them in every procurement that will be going on. So I want to again thank everyone for paying attention to this presentation from the beginning to the very end. Thank you very much, the chairman of the committee. Thank you, the chairman of the Nigerian Institution of Surveyor. Thank you everyone for paying close attention. So now it's time to take your question. I'll be taking your question in the comment section in the WhatsApp group, or even in the comment section in our YouTube channel where you might be listening to this presentation. You can drop your comments also on the platform or every other platform, and we'll do well to respond to you. Thank you for paying close attention. Once again, my name is Surveyor Okorocha, VC.